So, hello everyone. Let us do some questions on fluid mechanics. Okay, this is the first question. An incompressible fluid, kinematic viscosity 7.4 into 10 to the power minus 7 meters square per second, specific gravity 0.88 is held between two parallel plates. If the top plate is moved with a velocity of 0.5 meter per second while the bottom one is held stationary, the fluid attains a linear velocity profile in the gap of 0.5 mm between these plates. The shear stress in pascals on the surface of top plate. Okay, so let us see the diagram first. Okay, let us this is okay, let's suppose this is our plate number 1 and this is our plate number 2. Okay, so in between there is a fluid. Okay, there is a fluid. Okay, and the upper plate is moving with a velocity, okay, that is equal to given 0.5 meter per second, 0.5 meter per second. Okay, and the bottom one is fixed. This plate, the bottom one is fixed. So the question has asked the shear stress in Pascal on the on the surface of top plate. Okay, we need to find out the shear stress in this plate. Okay, so our formula, okay, Newton's law of viscosity, if you will apply, then we will get tau is equal to mu du divided by dy. Okay, this is by Newton's law of viscosity. In this we have the kinematic viscosity of 7.4 of this liquid. Okay, so the kinematic viscosity, that is equal to 7.4 into 10 to the power minus 7. Okay, it is given in the question. So but here in the formula this is dynamic viscosity. First we need to convert this kinematic viscosity into dynamic viscosity. So we have a formula that mu by rho is equal to nu. Okay, so the mu will be is equal to rho into nu. Yes or no? Yes. So the rho is given in the question, that is, okay, the specific gravity is given 0.88. So the rho will be 0.88 into 1000, okay, into the nu is 7.4 into 10 to the power minus 7. So from here mu is, okay, we need to calculate this value. And the value is 6.512 into 10 to the power minus 4, and the unit will be kg per second. Okay, sorry, meter square per second. Okay, we have now mu. So in our formula, I'm writing it again. Tau is equal to mu du divided by dy. Okay, if in the question, if we'll see that it is given that linear velocity profile. What is linear velocity profile means? Linear velocity profile means du by dy, okay, will be equal to v by h. Okay, so what is v and what is h? The v is the velocity of the uppermost layer and h is this height. Okay, see, the velocity profile is linear. Okay, here the velocity is 0 and here the velocity is v. So as it is a linear velocity profile, we can write du by dy is equal to v by h. So du by dy will be equal to v is given, that is equal to 0.5 meter per second, and h is given 0.55 mm. Okay, so du 0.5 meter per second divided by the gap is 0.5 mm. It means in meter it will be 0.0005 meter. Yes or no? So this value will come to us as 1000. Okay, here we have found out the value of mu, and here we found out the value of du by dy. Now the simple thing that we need to do, just multiply both. So mu is 6.512 into 10 to the power minus 4. 6.512 into 10 to the power minus 4 into du by dy is 1000. So our final answer will be 0.6512 Pascal. This is our tau. Okay, let's move to the next question. Here, a 90 Newton rectangular solid block slide down a 30-degree inclined plane. The plane is lubricated layer, a 3 mm thick film of relative density 0.90 and viscosity of 8 poise. If contact area is 0.3 meters square, the terminal velocity of the block. Okay, see. Okay, let's suppose this is an inclined plane. Okay, it is the angle is 30-degree. That is given in the question. Okay, and it has a layer of viscous fluid. Okay, so it has a layer of viscous fluid over it. Okay, and there is a block. Okay, there is a block that is not visible. Okay, let's do it in white. Yes. Okay, similar color. Let's try a different color. Okay, this is perfect. Yes, here I have a block. Okay, this is our block. Okay, and its weight is, let me change the color. Its weight is given, that is equal to 90 Newton. Okay, this is given. And the thickness of the liquid layer is, okay, this is perfect. Okay, this is, the thickness is 3 mm, that is 0.003 meter. Okay, and the area is given 3 meter square. Okay, and the viscosity is given 8 poise, that means 0.8, right, kg per meter second. Okay, kg per meter second. Okay, every data is given, and the relative density is 0.90. okay, we'll use that later if required. The question has asked the terminal velocity. Okay, so what do you know, what do we know about the terminal velocity? One thing, that is Newton's law of viscosity. That's simple. F is equal to mu a du by dy. Any doubt? I hope there will be no doubt. Okay, so this F, what is the F? What is this F? This is the force that is parallel to the surface. Okay, this is the F. Okay, this is F. So first we need to find out the value of this F. Okay, how to find out this? See, this weight is the only external force. Except this weight, there will be no external force. Okay, yes, there will be a force in this direction. Okay, that will oppose the motion, and this is only the viscous force. Okay, this is the viscous force. And then what is this? This is the component of the weight that is pulling down the block downwards. So if this angle is 30, then this angle will also be 30 degree. Okay, so this F and this viscous force must be equal for this terminal velocity, because the terminal velocity means the velocity is constant, acceleration is 0. So if the acceleration is 0, then this force, the viscous force, and the weight, the component of the weight in the downward direction must be equal. So we need this one, but if we will be able to find out this one, then ultimately indirectly we will get this one, the viscous force or not. So this F is equal to, see, this weight, okay, this weight will have two components. One is in the downward direction and the other is in this direction. Okay, so this component, okay, this component in the downward direction, okay, in the downward direction will be equal to 90 cos theta or not, 90 cos theta. Okay, so the F is 90 cos theta, yes, is equal to, the mu is 0.8. okay, the area is 0.3, okay, into, now du. Okay, see, here in the question it has not mentioned linear velocity profile, but we'll assume that it will be linear velocity profile. So the du will be v, okay, and the dy will be this gap, and this gap is given, that is 0.003 meter. Okay, from here we can easily find out the value of v. Okay, the v will be equal to 90 cos theta divided by 0.8 into 0.3, okay, and multiplied by 0.003. okay, the v is 0.974 meter per second. Okay, this is the answer. Thank you.